Hello everybody, in this video we are going to be talking about how to find critical values of a parabola using Desmos and a TI-83 or 84. So first off, I have here a quadratic function, 2x squared plus 9x plus 5. Right now it's written in standard form. The only thing I can tell you about this function is that it has a y-intercept of 0, 5. That's about all the information I know. Using Desmos, however, all hail Lord Desmos, I can figure out the x-intercepts just by clicking around. So I already know it's going to be negative 3.851 and negative 0.649. And I could even click and drag down here to get my minimum value, right? It's an upward opening parabola, so it has to have a minimum value of negative 2.25 and negative 5.125. So using Desmos, it's pretty easy to just kind of click and drag things around. Now on the quizzes and homework, most of you guys will be using a TI-83 or TI-84 device. So yours is going to look something like this. Let me kind of move things around so we are all on the same screen here. There we go. So here I have my TI calculator. So I'm going to go into y equals, and I already have mine punched in, but if you guys haven't yet done so, feel free to do that. Pause the video here if you need to. And if I look at the graph, I'll notice it looks pretty similar to what I had on Desmos. Neat. So my goal is I need to figure out what is that x-intercept right here, what is that intercept right here, and as a bonus, we're even going to find that vertex, although doing the negative b over 2a process isn't too hard. So what our calculator is looking for when it finds an x-intercept is when does our graph switch from being positive function values above the x-axis to negatives? Or when does it switch from being negative to positive? Because anytime we switch from a negative number to a positive number, we have to go through the value of 0, and that's what it means to be an x-intercept. So here's how we do this. First, I need to go to my calculations menu, so second, and then trace. Right above trace, you'll notice it says calc. That's my calculations menu. I'm trying to find an x-intercept, which is a 0 of the graph, so option 2 is my selection. Now down here, it's going to ask for a left bound. If I'm trying to find this point right here, this is my x-intercept, I need to take that cursor and I need to move it somewhere to the left this way from that x-intercept. So I'm going to scooch over to the left and I need to go past the x-intercept, so right about here is fine. I could go further if I wanted to because I'm still on the left-hand side. Once I've established my left bound, I'm going to hit enter, and now it asks for the right bound. So I'm going to scooch over to the right. Any spot to the right of that x-intercept will be good. I'll hit enter here. You'll notice it put these two little triangular arrows up at the top. That means somewhere in between that range, our x-intercept happens. Lastly, it asks us to guess. You don't have to do anything here. You can just hit enter to skip it. And shadaisy, we get our answer. Holy cannolis. Now, one advantage, and possibly the only advantage, don't tell TI I said that this calculator has over Desmos, all hail Lord Desmos, is that this one gives you more than 3 decimal places on a quiz or test. We probably won't ask you for that many, but this one is slightly more exact. All right, so we're going to do that exact same process now because I want to get this x-intercept right over here, the second one. So we're going second, then calculations. Option 2 to get a 0. I need my left bound, so somewhere to the left, basically anything on this side of that x-intercept right here is fine. Now I need my right bound, so I'm going to go to the right till I've gone past it. Right here is fine. And guess I can skip. So right there we have negative 0.649, which is what we knew we were going to get anyways from Desmos. All hail Lord Desmos. Now last thing we are going to figure out is this vertex. You guys already know how to do this doing the negative b over 2a process, which is pretty snazzy. But our calculators can do it in a similar process as finding our x-intercepts. So to do this, we first have to recognize our vertex here. Is it a minimum or a maximum? Well, since it opens upward, that means we hit a low point, meaning that that is a minimum value. When I go to my calculations menu, option 3 is going to be my choice, the minimum value. So it's going to send me through that whole left bound, right bound thing. Right about here-ish is my vertex. I need to make sure I'm clearly to the left of that. So right about here is totally fine. I'm going to hit enter to confirm. Now it asks for a right bound. I'm going to scooch over to the right. So now I'm clearly to the right of my vertex. You'll notice just like before, it gives me these two little arrows. So somewhere in between these two values, we hit a low point. We hit a minimum. We can skip through the guess. And lo and behold, we have our vertex. Yay. Now, one thing to be aware of, you guys might encounter something, not necessarily with the vertex, but for x-intercepts. If the y value doesn't say 0, sometimes it might say like 3.2 e negative 10. That e really means times 10 to the something power. So 0.000000000 something. Basically, it's your calculator running very, very close approximations to 0 without giving you exactly 0. But we can trust it's close enough to find the x-intercept. Hope this makes sense. If you have any questions, don't hesitate to email me. Leave a comment on the video if you want to. I'll respond to that as well. And good luck mathing.